precipitate, or how much you need to add to just start precipitate. Those are the wordings of the questions that you'll get. Already online on eClass, I have posted a KSP assignment, blank assignment, and the worked out solutions assignment. So you've got the two just like on the KE test. So you can get those anytime you want, start working on them at your own pace. Okay, so on eClass, those are already up there and running. So what you need to do is we set up our KSP expression, and we find this sample Q, this number that we can compare to the KSP value. Okay? So what's important for you guys to know is that you have to know which of the two products will form the precipitate. Okay? And as I said, we'll go through the reaction. And even though we might have done this, I'll go through this one again anyway. So what we're doing is we're doing this trial KSP called Q. And we're comparing Q to the accepted KSP value. And to calculate Q, we're going to find the concentrations of the two ions in the mixture. So the concentrations of the ions are going to change because we're taking two solutions and mixing them together, so we're adding volumes. So our volume changes, so our concentration changes. So we have to find the concentration of our new concentration of the ions, put that into KSP, compare Q to KSP. If Q is greater than KSP, we get a precipitate. If Q is less than KSP, there's no precipitate. And a kind of important one, if Q is equal to KSP, we've got a saturated solution that is about to precipitate if any more is added. Okay? So, take a look at sample problem number 3, and we'll start. Take a couple minutes to go over everything. So, will a precipitate form if 20 mils of 0.01 molar calcium chloride is mixed with 20 mils of 0.008 molar sodium sulfate? So here's our two solutions. These are the concentrations of each of the solutions. We're going to take those two solutions and we're going to mix them together. If you remember last year you did the percent yield lab. We took the two containers, mixed them together, got the white powder that we collected in the filter paper, right? We let the filter paper dry, determine the mass. That's a precipitate reaction. In fact, it's that reaction. We formed, no, this was sodium carbonate. Calcium carbonate was what we formed. But anyway, so here's what happens. In this, we got to take a look at the reaction. So if I'm going to react these two things, what are my two products? So we get sodium chloride and calcium sulfate. Of those two products, one of them will be the precipitate. Which one is going to precipitate out? How do you know? There's sodium in here. I can provide you with a list of solubility rules so you can help determine which is the precipitate or not. But they're shortcuts. If it has sodium in the formula, it will always be soluble. If it has potassium in the formula, it will always be soluble. Or if it has nitrate in the formula, it will always be soluble. So sodium, potassium, or nitrate will always be soluble. If it has any one of those three, that's your soluble product, the other product your precipitate. And that's important because that's what we're trying to find out. Remember, that's what we've been studying, right? The precipitate forms at the bottom of the solution. That's our equilibrium system. Because what we've got is we have ions that are precipitating out of solution at the same rate that the solid is dissolving into its ion form. That's our equilibrium. So it's the precipitate that we're concerned about. So when I give you a KSP value, that KSP will be for the precipitate. So, two possible products, sodium chloride and calcium sulfate. This is slightly soluble. That's your precipitate. All you need to know is sodium, that means that's going to be soluble. The other one's going to be a precipitate. It's always going to be the precipitate. Okay? All right. So then the KSP value I give you is the KSP for calcium sulfate. Write the ionic equation for calcium sulfate. Write the KSP expression for calcium sulfate. Okay? So from our appendix, there's the KSP value for calcium sulfate. There's the ionic equation. There's our KSP expression. Boss!
Boss, how's it going?
How are you? Welcome to
No, the other thing.
Welcome to chemistry.
Speak with the Liam, please.
You can speak to Leon all you want, because
Thank
he's
you.
not a Leaf fan.
He's not?
Like
I don't want to talk to him either.
living with
No, just reading stuff. Thank you, sir.
You're welcome, sir, anytime. Sorry, TJ, I didn't mean to bring that up. I know it's still painful. I'm sorry. That was a tough one last night. I will admit, that was a tough one last night. Okay, so we know this is going to be Q. So we're going to make that Q, and what we're going to do is we're going to compare Q with the accepted KSP value. Okay? But in order to calculate Q, I need to know the concentration of calcium in my new mixture and the concentration of sulfate in my new mixture. How do we do that? There's the concentration of calcium from our first beaker. And then there's my concentration of sulfate in my second beaker. We're going to take those two beakers and pour them together. I've got 20 mils added to 20 mils, so my new volume is going to be 40 mils. After we mix everything together, we now have a 40 milliliter solution. So what we do now is I have to find the concentration of calcium in my new volume. So we take the old concentration, the former concentration of calcium that we started with, and we multiply that by the old volume divided by the new volume. So my concentration, my new concentration for calcium is going to be equal to the original concentration multiplied by the old volume divided by the new volume. And that's going to give me my new concentration of calcium. Everybody okay with that? Do the same thing with sulfate. Go ahead. See what you get. Any questions, please ask now. Hopefully everybody got that. So here are our new concentrations. No problem. Where do they go? My new concentrations go into my KSP expression. I calculate what my KSP would, well, it's not KSP anymore, remember? We're saying we're going to calculate Q based on those new concentrations. So go ahead, calculate Q based on the new concentrations. Once you know Q, compare that to the accepted KSP value. Does it precipitate form? Yes or no? put that into Q, and we get that number there. So our concentration for calcium is here, concentration for sulfate goes there. Nothing is squared because they're all 1 to 1. Find Q is equal to that. Well, that number is lower than that number. This is my KSP, this is Q. Q is less than KSP, no precipitate. The only little twist I can put to this question, sample problem number 4. Read what it says. Do you want a few minutes to try it on your own? The only thing I'm going to say to you, when we read this question, how to figure out how to do it. The question, without looking at the numbers, forget the numbers, because like I said, we look at numbers and all we think is, where do I plug it in? Where do I put that in? Where's that number fit? What equation do I got to use? Forget it. What's the question asking? The question's saying, calculate the maximum mass which can be added without causing any precipitation. So I want to find out how much I can add to a solution so it won't precipitate. The maximum I can add that won't allow a precipitate to occur. So what kind of solution is that? It's saturated. How much, and I don't care what the formula is, how much do I need to add to make a saturated solution? So how does that relate to KSP then? Equal. So my sample Q has to equal KSP. So I'll use my KSP value as my Q. I'll leave it at that, see if you can figure it out. And one thing I will tell you just really quick as you're starting, we are going to use these two triangles a lot. You know, your concentration is equal to number of moles over volume, and mass is equal to molar mass times the number of moles from last year. You got to know those formulas. Anybody has any questions, please do not hesitate to ask them. See, instead of this state, at the state height, and they try to say, press on it all at once. Just take it a little bit at a time, put it in what you got, and see it. That's good there. Where's your gas? So we know because we're looking for saturation, we know that is going to be equal to Q, right? So we're doing an equation, we know our case be already from that, right? So put that in. I wouldn't erase that because that's a marker. And how to do it, right? We'll go over this. Okay, do you know calcium concentration? Yes. So what's going to happen? Right now? Yeah. When you find that, what's the next step? That's it. I think a lot of people, and you know, over the last couple of classes I've been walking around, and I'm trying to find out why this concept that, I mean, I understand it's relatively easy for me because I'm doing it, but why create so much difficulty? And I think people are looking at, and they're getting this far, okay? They're getting this far, because those are the first two steps, and then they're looking at going, what do I do now? And they stare at it. Like, what do we do now? What do I do with this? Well, my point is, when you get to here, instead of trying to answer the question, what do I have? Okay? We get caught up in, I have to answer the question. I have to be able to go from A to Z without going through the rest of the alphabet. You know, I got to get from here to the third floor without using the stairs. Elevator. Elevator's broken. We can't use it. Now what do? We got to use the steps. So I look here. What do I know right now that I can put into that? You know the concentration of calcium. So you know that. So you can put that in there. So that's one thing I know right now. I can cross that off. I know one other thing though. What else do I know? What kind of solution am I trying to create? Saturated solution, right? Because I'm trying to add without causing precipitate, so I want a saturated solution. So what do I know about Q and KSP? They're the same. So now what else do I know with that equation? Nice and loud? I know the KSP. Q's got to equal that, so I know this. So I got that done. Well, what can I now figure out? If I've got that and that, what can I figure out? Seriously. Let's go. I know that and I know that. What can I now figure out? Carbonate concentration. So do that. Forget what it does to the question. I've got this and I've got this, so I can figure that. Do that. Then take a step back. What does that tell you? Okay? Instead of saying, well, because I know what's happening, because I said, see it in your eyes. When I ask, what can I figure out? You're all said this, but then you're, instead of stopping, you're going, well, how does that help me? Where's that go? Well, I don't know. Let's figure it out first and see what it says. right? Don't try to go too far. One thing at a time. I can do that. So figure out that. Okay? Forget the question yet. Just go that far. I know calcium is 0.004, and I know KSP has to equal Q, so I know that value, so I can figure that. Just copy that down for a second, and then we'll figure out what to do with it.
How come this question?
This one's just once dissolved. Once dissolved, or any dissolved.
Okay, do you know where to go now? Let's take a look at it. How about you? Do you know where to go now? No problem. How about you, Alex? Do you know where to go now?
No.
No problem. Okay, so let's sit back and figure it out together. I now know carbonate concentration. In order to create a saturated solution, I need to have that carbonate concentration. Is everybody okay with that? Sure, Philip, you're not? Okay? Okay. What does that mean? What am I adding to make a saturated solution? I'm not adding just carbonate. Where's the carbonate coming from? From here. Okay. So I got to figure out what mass of that. Do I know anything about carbonate and sodium carbonate?
They're the same. Concentration is the same.
They're in a 1-to-1 ratio. So the concentration of sodium carbonate is going to be the same. Right? So if I need to add this much carbonate, I'm going to have that concentration of sodium carbonate because they're the same. So if I know that, then this is going to be right? That's the concentration of sodium carbonate I need. So now, all I'm going to say, and I don't mean, like I'm not being sarcastic here, but let's go back to grade 11. And you can all answer this question, and did answer it in grade 11. How much mass do I need to add? How much mass does that concentration represent? So what are the units for concentration?
Moles per liter.
Moles per liter. So that's concentration. What equation do I need to use to find mass? You only know one.
N equals C.
Sorry?
N equals C.
To find mass.
Oh.
We need M is equal to molar mass times the number of moles. It's the only one we know. Hopefully we can figure that out, right? Everybody knows how to figure out molar mass. So I need number of moles. Well, all I've got is concentration of moles per liter. How do I find number of moles? Number of moles would be concentration times the volume that I can then put in there to find mass. Right off the grade 11 exam. So, work on it. I'll go through it one more time. So everybody go get the mass. Anybody who still doesn't know, I'll go through one more time. The kind of the thought process involved. Okay?
But it doesn't change.
I've got a KSP for calcium carbonate. So without causing precipitation of calcium carbonate, so I know calcium carbonate is the one I'm going to use in my KSP expression. So calcium carbonate is calcium times carbonate, plus carbonate, sorry, in equilibrium. I write my KSP expression from the balanced equation, so we get to this far. So now we start to take a look. I've got that KSP expression. What do I need to do with it? I'm looking at precipitation. So I know that precipitation I'm going to compare Q to KSP. I want to add something so it's just not, without causing any precipitation. So the relationship between Q and KSP is that they're equal. So that means I can just do this. Okay? If Q and KSP are equal, well, I know what KSP is. I've got it right there. So that means this is equal to... Okay, so I've got this part of my equation done. Do I know anything else with my equation? Yeah, I got, and it's moles per liter, so I know that's calcium concentration. I know that much because I know my calcium concentration. So look at the equation. I know A, I know B, and I can figure out C. Simple algebra. So we calculate the carbonate concentration. How does that help us? Well, it does because I'm trying to add sodium carbonate. This is my source of carbonate. All of my carbonate is coming from that. So if I know the concentration of carbonate, I also know the concentration of sodium carbonate because for every mole of carbonate I produce, I had to use a mole of sodium carbonate. So if I have 0.01 moles of this, I needed 0.01 moles of this to get it. So if I've got 2.2 times 10 to the negative 6 moles of this, I got 2.2 times 10 to the negative 6 moles of that. So that becomes the concentration of sodium carbonate. Because carbonate's 1-to-1 with sodium carbonate. Well now, based on everything I've learned in grade 11, if I know the concentration and I know the volume, I can find the number of moles. Once I know the number of moles, I can use number of moles to find the mass because I also know the molar mass. So, back to the slides, 9 to 12. We'll start, I think 9 is the first one, first precipitation. Give everybody a chance to copy that down, then we'll work on those slides. So go to the first precipitation slide, I think is number 9. The end of the unit, by the way, just the end of that chapter, all that dissolving precipitates, forget about it, don't worry about it. Not gonna, you got enough to worry about, forget it.
Why is 5 the volume?
Most of it's just common sense anyway. If you want to dissolve or precipitate, add more salt.
Divide by 2. Or you multiply by 2.
Right? So that's all we're
Divide
going
by
to
2
do.
because of 2. Why didn't you do that? Nothing.
But that's Na2CO3 is that solid.
Oh yeah. Oh, no.
How can that be a volume? So, why is 5 the volume of Na2CO3?
Y is 5 divided by...
Why is 5 the volume of sodium carbonate?
We're here?
Yeah.
5 liters. Moles is equal to concentration times the volume. This is the concentration of sodium carbonate,
Uh-huh.
right? So if I want to find the number of moles, the volume came right here. Right? if 5 liters of water has a concentration of calcium equal to that, how much sodium carbonate can I add? So I've got a 5-liter container that already has calcium in it. How much sodium carbonate can I add so that the calcium reacts with the carbonate ion to just not form a precipitate?
Okay.
So we need to find out how much carbonate I can add. So that means we have to, our KSP is going to be equal to Q. Okay? So I find carbonate concentration. So that's the concentration of carbonate that I need in here to be able to not form a precipitate, where Q is equal to KSP. Okay? Where does this come from? It comes from up here. All of this comes from here. So carbonate 1-to-1 with sodium carbonate. Right? So that means to generate that this concentration of carbonate, I need this concentration of sodium carbonate. So that's the concentration of sodium carbonate I'm going to have in here. So now I have to say, well, if I know the concentration and I know my volume, I know the concentration of sodium carbonate I need, I know the volume I have, how many moles of sodium carbonate does that represent? Now I know how many moles I've got, so the mass is equal to the number of moles times the molar mass.
Okay.
Okay? So that's the total mass of sodium carbonate I can add to that 5-liter container without causing precipitation. All right. Stupid board. Mark, you messing around with my board again?
Maybe.
There you go. Try that. How are we doing?
Was there that you need to get more often?
Okay, let's go through this relatively quickly. We'll do another one. Does a precipitate form? I have two solutions. I've got this one, and I've got this one. Okay, so we take a look. I got 10 mils of that, 90 mils of that. Are we going to get a precipitate forming? So, when we go through the situation, I've got two possible products. The two products are silver iodide and potassium nitrate. Well, we know that potassium nitrate is going to be soluble. It's got potassium and nitrate in it. So we know that the silver nitrate is our precipitate. Ionic equation and our KSP expression. There's our KSP value. So if I'm trying to find out if a precipitate is going to form or not, I'm going to set up that sample Q, and I'm going to compare Q to this accepted value for KSP. So, in order to calculate Q, I need to know the concentration of silver, I need to know the concentration of iodine. So we'll deal with silver first. Okay? Silver concentration. I take the old concentration of silver, multiply that by its old volume, divided by the total volume, because 10 plus 90 is 100 mils. The good thing is you don't have to convert to liters. This is the ratio, doesn't matter. So you can leave it at 10 mils over 100 mils, 0.01 liters over 0.1 liters, doesn't matter. Okay? We get that concentration of silver. Do the same thing with the iodine, because iodine is the next part of it. We take the initial concentration of iodine, which is here, multiply that by its old volume, divided by the total new volume, and we get that concentration. Put those two numbers into my KSP expression. Silver concentration, iodine concentration, multiply them together. We find out that, Q is greater than KSP, 10 to the negative 13 versus 10 to the negative 17. Therefore, precipitation does occur. Go ahead, try slide 11. Just wait for a few people to finish this. Any questions with this slide?
우리 하는 스포츠 괜찮아?
Okay. There's the answer.
What's the charge? What's CR2? Diagonal signature. What's this for? It's not safe. It's not safe. Smack the button.
The charge +2 and -2.
Are you ready for physics? Oh, funny. Wait, let me treat this for science. Oh, yeah.
That's right.
Look at my contraction too. Let me see it. Let me see it.
Let me see.
Nice Thank you very much. Nice.
Oh, this QT. Yo.
That's 7.35 times 10 to the negative 6.
Oh shit, those are 4, so that's true.
Yeah. If it's by itself, it is. This is as an ion.
Oh,
Yeah. If we were reacting the iodine by itself, for sure, absolutely. But because it's the iodine, it's the ion from silver iodide, it's by itself.
So tired. Is that a tape? So,
Everybody okay with that? Okay, let's try this one. This is the last one. See if you can get that. Hey, buddy. Good. You missed me?
Yeah, wow. What
How's-
are you doing?
KSP calculations, predicting precipitate reactions.
Oh,
They're
you
crying.
know how to do that?
They're crying.
You didn't take me off the E-class yet. I'm still been reading your notes.
Did I not take you off? See how much I miss you?
Actually, I'm not sure. I'm sure. Last time I did though, I was still on the
Well, I've sent out a couple notes since then, so I did clean it up a while ago. I just couldn't let you go.
Last year.
Take care, guys.
You guys have fun.
What is it?
3.5.
Did you get?
17.
No, you didn't.
So
You just
yeah.
found it.
Yeah. 2.82. 17. Is that 7?
Okay, let's take a quick peek here, because I do want to introduce acids and bases really quick, just to show you, and we'll get through stuff. 1 liter solution, good, because that means we don't have to worry about converting any volumes or anything like that. Contains 5 times 10 to the negative 5 molar silver ions. What mass of potassium iodide would you have to add to the solution to begin precipitation of silver iodide? So, first thing, we know we're going to precipitate silver iodide, so we know what silver iodide is going to be our ionic equation. From the other question, we realize our KSP for silver iodide is 8.5 times 10 to the negative 17. Now, again, understand what the question's saying. I want to add potassium iodide to just begin precipitation. So in other words, I want a saturated solution. So I want Q equal to KSP. So that means this is the equation I'm going to use right here. Okay? So I know KSP already. I know my silver concentration's right here. So what I can do is I can calculate my iodine concentration. So I calculate my iodine concentration according to the equation, and I find that the iodine concentration is equal to this. Okay, there's my Q, KSP value. There's my concentration of silver, and I'm looking for iodine concentration. So, to solve for iodine, we find that's the concentration of iodine I need. So that's the concentration here that I need. But because iodine is 1-to-1 with silver iodide, it's also the concentration of silver iodide I need to have at the end of it. So I have my silver iodide. The iodine concentration must be greater than 1.7 to the negative 12 in order to cause the precipitate to form. So the mass, okay, I'm not going to do it this way because you're confused already. So first thing we need, well, it's just there is a shortcut you can take because it's 1 liter, but I'm not going to get involved with that. So I've got a concentration. I need to know the number of moles. So my number of moles is equal to the concentration times the volume. The concentration of silver iodide is going to be 1.7 times 10 to the negative 12. And my volume is 1 liter. So that means that my number of moles is 1.7 times 10 to the negative 12 moles. Now I got to find the mass based on that number of moles. The mass is equal to the molar mass times the number of moles.